Hello and welcome to this video for Chemistry 30. Today we're going to continue with naming organic molecules, focusing on halides and alcohols. So we're almost done all the molecules. The next video will have the last two. So halides and alcohols. Notice how all the compounds we've done so far have involved only carbon and hydrogen. We are now starting to add other elements. X, which stands for a halogen. Things like bromine, chlorine, iodine, fluorine, okay? And OH, so oxygen bonded to a hydrogen, called a hydroxyl functional group, okay? Those are the two we're gonna look at now. Now these compounds, including the next two, are all something called hydrocarbon derivatives, okay? Hydrocarbon derivatives. This means they have more than just carbon and hydrogen. They have other elements like oxygens, or X again can be a halogen. Okay, so they're more than just a hydrocarbon. They are called a hydrocarbon derivative. All right, so like I said, we're going to focus today on the alcohols and the halides. So starting with alcohols, you'll see the generic formula for an alcohol written as ROH. R means any organic molecule. Okay, for us, we're usually going to be focusing on having an alkane or a cycloalkane or the benzene ring. That's what the R is going to be for us, but it could technically be anything, okay? They have the OH called the hydroxyl functional group. OH is called the hydroxyl functional group. So for example, the simplest alcohol you can have is CH3OH, okay? So that's one carbon bonded to the OH. Okay, now the OH, technically, yes, there's a bond between them. The oxygen has two bonds, but we always just write them side by side because together they make up, like I said, this hydroxyl functional group. Now the name of this is methanol. Okay, so very similar to the alkane name methane, but the E is gone and there is an OL ending. And that's essentially how we deal with alcohols. A little more complicated than that for when you get more carbons, but this is the simplest alcohol you can have. Now they are going to have higher boiling points because they have hydrogen bonding and they're polar, okay? They're polar, so they have all three forces: London dispersion, dipole, and hydrogen bonding. Okay, so if I were to compare two hydrocarbons that have only one carbon, but one of them has the OH and the other doesn't, there's a big difference in their boiling points. All right. Solubility actually depends on their length. Okay. The hydroxyl functional group is polar, while the rest of the carbon chain is not. So small alcohols will be soluble. This is when they have 6 or less carbons. They are going to be soluble, whereas 7 carbons or more are non-soluble. Okay, so it depends on the length of your chain, because again, if you have an alkane, right? 1, 2, 3, 4, 5, 6, 7. There's an OH branch on one end, but the rest of the compound is tetrahedral with terminal hydrogens, which would make it kind of nonpolar. So even though the OH is a polar end, the rest of it is nonpolar, so it makes it not soluble if it's large, okay? So small alcohols, 6 or less, will be soluble, large will not. Some examples are antifreeze, rubbing alcohol, beverages, moistening agents. When you name it, the hydroxyl group takes priority in numbering, like a double and triple bond does. The OH needs the lowest number, okay? You are going to give it its aliphatic name, so alkane name, without the E at the end. You're also going to say the carbon where the OH is between the prefix and suffix, like we did with double and triple bonds, if you have more than 2 carbons. Okay, so when you have one carbon, again, we already looked at that. When you have two carbons, again, the OH, whether it's on this carbon or this carbon, it would be called carbon 1. Okay, so we don't need to say where the OH is. This would just be called methanol. This would be called ethanol. Okay, we drop the E and add all to it. But if you have 3 or more carbons, then you have to say where the OH is. Okay, because it could be on carbon 1 or on carbon 2. So the name of this would be propan-1-all. Okay, drop the E, put a number where the OH is, and end with all. Now, these compounds are the first ones that we're going to get into that can have more than one hydroxyl functional group. Okay? When you have more than one hydroxyl functional group, you're going to call it a diol or a triol or a tetraol. Okay? In this case, you're actually not going to drop the E anymore if you have a diol or triol. So for example, if I have 1, 2, 3, and let's say I have 2 hydroxyl functional groups, one there and one here. Notice how on this end I wrote it as HO instead of OH because it's the O that's bonded to the carbon, not the H. So sometimes you have to do it like that. Now I would number this 1, 2, 3. And the name would be propane. I'm leaving the E because I have more than one OH. It's 1, 3 dash diol. So propane 1, 3 dash diol. So if you have a di or a tri or a tetraol, you leave the E on the alkane name. Otherwise, when there's only one, I'll show you again. When I have only one hydroxyl functional group, the name was just propan, no E, 1-all. Okay, so if it ends with an O, we drop the E. That's what this says. If it starts with a vowel, we drop the E. But if it starts with a consonant like di or tri, we keep the E. Okay, so very important, careful spelling. Let's look at some examples. So I have my longest continuous chain, and the OH needs to be on the carbon of the longest continuous chain. Then I number it so that my OH gets the lowest number. I have to number it this way. So the name is butan, no E because there's only one OH, butan-2-all. Okay, butan-2-all. The next one, I have a line diagram. When you have line diagrams, your lines going to nothing or your zigzag corners are carbons, but there's no carbon here because it's going to the OH branch. Okay, so now to number it, I would start in this side because I need my OH to have the lowest number, which means I have a methyl branch on carbon 4. So it's 4-methyl. You still name the branches first. The parent is pentan, drop the E, -2-all. Okay? So 4-methyl pentan -2-all. Not pent-2-all, pentan. Okay, because this is an alkane. So we're keeping the alkane name. If it was an alkene, it would be EN, drop the E. We're only going to deal with alkanes and cycloalkanes and a benzene ring, though, for alcohols. Okay? Another example. I'm getting into a hydrocarbon, an alcohol that has more than one OH. Okay? So that's my parent longest chain that contains the OH on those carbons. There's also a methyl branch. I'm going to number it in this direction because either direction I number, my OHs are on 2 and 3, but when I number it this way, now my carbon is on, my methyl branch is on carbon 2. So if you can get the OHs to have the same number, then you can look at the branches and give them the lowest number. Okay, so the name for this would be 2-methyl, and the parent is butane. I leave the E, -2,3-diol. So again, we're leaving the E because I start with a D after as my suffix. Okay. Now, lastly, if you have the benzene ring with an OH on it, it is a parent. It's a new type of compound called the phenol. Okay. So I could have a branch on this, and I've actually seen this before, where my branch could be a benzene ring. You can have a benzene ring on a benzene ring. Okay. So this is my parent. My parent is the whole OH, the whole benzene ring with the OH, okay? The OH has to be carbon 1. So this is 1, 2, 3, 4, 5, 6. So on carbon 3, there is a phenyl branch, because remember the benzene as a branch is called phenyl, and the parent is called phenol, okay? Phenol for when you have the benzene ring with the OH on it. All right, so that is it for alcohols. Let's go on to halides. So halides are when you have, again, any carbon compound that has a halogen. So halogens, again, mean bromine, chlorine, iodine, fluorine, okay? So a hydrogen has been replaced by one of those halogens. They are not common in nature because if you have a saturated hydrocarbon, it would take a lot of energy to rip a hydrogen off and put one of those on. Some of their properties, polar or nonpolar, depending on the halogen groups. So again, your terminal atoms. If all terminal atoms are the same. So let's say we have all chlorines around my carbon. That would be nonpolar. Sorry, yes, that would be nonpolar. Okay, but if you have a couple hydrogens and a couple chlorines, okay, it's either all or none. So if there's different terminal atoms, it's polar. Okay, so if they're all the same halogen, they're nonpolar. But if they're not all the same halogen and there's hydrogens or other halogens, they are polar. A lot of them are toxic and dangerous. Things like Teflon and PBCs and CFCs, chlorofluorocarbons. Remember those back in Science 9, okay? They are very toxic and dangerous. When we name them, they become a branch. They do not take priority in numbering, okay? They do not take priority in numbering. So what that means, things that take priority in numbering are double bonds, triple bonds, and the hydroxyl functional group, okay? A halogen is just like any other branch, and you're just going to name it with the lowest branch sequence. You're going to number it with the lowest branch sequence, okay? So you look at all your branches, they're just another type of branch, all right? So if I were to find my parent chain, there's my longest continuous chain. That's just an alkane, a halogenated alkane, okay? So I'm going to number it so that these branches, the only branches, get the lowest number. These branch names are fluoro, chloro, bromo, and iodo, okay? So I have chloro, 2,3-di, because there's two of them, chloro, and my parent is butane. Okay, so I basically follow my parent chain for naming rules. This is an alkane, so I follow my alkane names, which is lowest branch sequence. Okay. If you have multiple branches, the halogen does not need to be the lowest number. So here I have a methyl branch, a fluoro branch, and an iodo branch around my benzene parent. I need to number it this way to get the lowest number sequence, right? You try starting at 1, go all the different ways and look at what your sequence is. This is 1, 2, 4. If I start somewhere else, I'm going to get 1, 3, 5, and so on. So the 2 comes before the 3, so we have to pick that method, right? Because you compare them 1 digit at a time. So 1, 2, 4. Now I have to name them alphabetically. We're getting lots of letters in here. We have a F, M, and I. So if you write your alphabet on the top of your quiz, A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, I'm not going to judge you, okay? Q, R, S, T, U, V, W, X, Y, Z. So like I said, I have an iodo, I have a fluoro, and I have a methyl. So the fluoro is going to go first. So it's going to be 2-fluoro dash my iodo's next, 4-iodo dash 1-methyl, and my parent is benzene. Let's see if we did that right. 2-fluoro, 4-iodo, 1-methyl benzene. Good. Okay, so alphabetical order for your branches, but lowest number sequence. The halogens do not need the lowest number. Okay, and that's it. All right. Now again, if you were to be writing the formula for this compound, it's not necessarily something we should forget to do. Okay. These are my carbons. Again, carbon, 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 carbon. Remember, when you have the benzene ring, you have alternating double bonds. So if I were to actually draw this molecule completely out, okay, I have alternating double bonds. I think I'm missing a carbon. 1, 2, 3. I am. 1, 2, 3, 4, 5, 6. Okay, there's my alternating double bonds. I have an iodine, I have a CH3, and I have an F. So where would there be hydrogens? When you have the benzene ring, every corner can have one additional thing. So those are the only hydrogens that we have. Okay, so we have C6. Usually when you have the benzene ring, we put the C6 together. Then we write down everything else it has. It has 3 H's. It has a CH3 branch. It has an F and an I. Okay, I don't know if that's exactly how you would see it in a textbook, but that's one way that you can write it, showing that, and sometimes I think there's a bracket around the methyl branch, and I don't know if the fluorine iodine goes first, the hydrogen, I don't know, it doesn't really matter the order of them, but that's essentially what you have. If you were to add it all up, you have C7H6Fi. Okay, but usually as a benzene ring, we put the 6 C's together, showing that it's a benzene ring. But you could write it either way on a quiz or test if it asks you for the formula. Okay, that's it. Thank you very much for watching this video.